Hello, Assalamualaikum. My name is Syamil Bakri Ibrahim. My metric card is CE190170. So today I would like to explain about this part 2 for this lab 1 lab sheet. For my part is 2.1, the scope diagram. So for this block diagram, I'm using for the under dam. We change the value to 36 per s square plus 4.2s plus 36. So this is the transfer function that we take from the library browser, just as transfer function. And then I already run this circuit, and then we go to the scope. This is the scope that we get for this value that we changed just now. So as we can see, this is transfer function. This is transfer function. The overshoot for this scope is 29.221%. The undershoot is 5.489%. Okay, and then for the rise time here, take from here to reach here, and we get 253.975 millisecond. So the statistic until we get the straight line from here until here is remain. So yeah, that's all for my part. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ridwan Shakir bin Muhammad Amzani. My matrix number is CE190085. So I will present to you about my part for 2.2, question 2.2. System transient and the steady state response characteristic. So this figure is the result or output that we got from question 2.1. So I will explain for the system transient and steady state response based on question 2.1. So the system transient response for this transfer function can be categorized as under damped. The damping ratio is 1.111. So the response rise quickly here. The response rise quickly towards steady state and finally settling at steady state. So based on this graph, the rise time of the from the graph is 253.98 millisecond. The satellite time is around 2.213 second, and overshoot percentage is 29.221%. So uh, that's all from for the system transient. So and then next we got for the steady state is steady state error is about 4.2. So I think that's all from me. Thank you.
Assalamualaikum and hi. My name is Nur Aini Nadira binti Kamal Arifin and the metric number is CE190049. So for this lab 1 part 2, my part is task 2.3, which is compare result with your risk. So from the transfer function is equal 36 over s squared plus 4.2s plus 36. This is the value that we will put in the block diagram for the simulation. So next is Wn squared equal to 36, Wn equal to 6, to 36, power of 2. Then 2 zeta Wn equal to 4.2, 2 zeta 6 equal to 4.2. So the value for zeta is 0.35. So as the damping ratio is zeta equals 0.35, smaller than 1, the system is called overdamp response. Then from the manual calculation, the values of simulation are slightly different compared to the values of transient response due to the steady state error in the response, which the value is 4.07. So for the overshoot percentage is equal exponent negative zeta 5 over square root zeta squared minus 1 times with 100%. The value 0.35 is the value for zeta. So the answer is 0.107%. For the rise time, PR, pi minus cos negative 1 is inverse cos zeta over Wn set zeta squared minus 1. So the answer is 677.47 millisecond or 7 millisecond. Then for the settling time, 5% is S equal 36 over zeta W times by Wn. So the answer is 17.142 seconds. So this is the table. We can see the difference between calculation and simulation. Damping ratio is 0.35 for the calculation, and from the simulation is 1.11. The overshoot percentage is 0.107% from the calculation, and for the simulation is 0.505%. The rise time for the calculation 677.47 ms millisecond for the calculation, and then simulation is 549.874 millisecond. And last, for the settling time, from the calculation, we get 17.142 second. Then from the simulation is 1.136 second. So that's all from me. Thank you.
Hi, my name is Zhongxun Lin. Matrix number is CE190008. So for this lab 1 part 2, I will explain about 2.4, which is study the transient and steady state response by adding a transfer function to the system. So now let us see the block diagram for this for the 2.4. So this is the block diagram. So basically we just using back the transfer function from the previous lab. So we only change the value. So for this transfer function value, we also get it from the nice control textbook. So except for this transfer function, we also add on another one transfer function here, 1 over s plus 1, and then add on what we call we also adding the feedback loop system in this block diagram. So that's all for the block diagram. Let us see for the output waveform, output graph. So as you can see here, this is the graph when we run the block diagram. So this is the graph that we obtain. So this is an critically damped damping ratio, the response. So as you can see here, the right side here, there is the value for we can see the output value for this graph. So here is the overshoot value, which is 0.505%. And then the rise time, 549.874 millisecond. And then this is the settling time, 3.501. And then And then we can see here, this is after the overshoot. Here, there is the steady state response, steady state response. So in order we add on the feedback loop system, we can obtain the stable steady state response for this graph. So that's all for my part. Thank you.